This video looks at 5 examples of simultaneous equations. Now, in simultaneous equations we have 2 equations in the question with 2 unknown letters in. Now, there are various ways of solving these equations, and I'm going to suggest one way of approaching it. Now, first of all, look at the y part of the equation. The first aim is to make the number of y's match in both equations. So, if I were to double the first equation, I would get 10x plus 6y equals 70. If I then triple the second equation, I get 9x plus 6y equals 69. So I now have the same number of y's in both equations. Now, I've got a plus 6y and a plus 6y here. They have the same sign. If I now subtract the second equation from the first equation, watch what happens. 10x take away 9x is 1x. The 6y's cancel out. And 70 take away 69 equals 1. So 1x equals 1, i.e. x equals 1. So we found one of the letters. I now just want to find what the second letter is, i.e. y. I pick any of these equations. This looks the simplest to me. Now, because I know x is equal to 1, I can replace the x here by 1. So 3 lots of 1 plus 2 lots of y equals 23. Now 3 times 1 is 3, plus 2y equals 23. Because I have to add on 3 to get to 23, 2y must equal 20. In other words, y must equal 10. So x equals 1 and y equals 10. These are the solutions to the 2 simultaneous equations. In the second example, I know the signs are different, but we approached in the same way. I want to get the number of y's to be the same. Now in this case, if I merely double the bottom equation and keep this one the same, so I'll keep this one the same, and double this equation here, 2x plus 2y equals 12, we now have the same number of y's, albeit with a different sign. Now, to make different signs cancel out, we just have to add the 2 equations together. 4x plus 2x is 6x, minus 2y plus 2y cancels out. 18 plus 12 is 30. So 6 times x is 30, x must equal 5. That is one of the variables, but if x equals 5, if I pick the simplest equation of these 4, probably this one here, x is 5, 5 plus y equals 6, therefore y must equal 1, because 5 plus 1 equals 6. So these are the 2 solutions to the original simultaneous equations. And in the final one, even more negatives, but again focus on the y's. If I double the bottom equation, I will get 4y, which will balance off the 4y above. So I will keep this equation the same. I will double the bottom equation, minus 10. The signs are different, but I've got 4y in both equations. Now when the signs are different, we have to add together the equations to make them balance off. Now I must be very careful here. Now minus 3x plus 2x is minus 1x. 4y and a minus 4y cancels, and 11 and a take away 10, 11 take away 10 is 1. So minus x is 1, therefore x must equal minus 1. So that is one of the solutions to these pairs of simultaneous equations. But if x equals minus 1, if I pick, for example, the first equation, x is minus 1, minus 3 times minus 1 goes to plus 3. So 3 plus 4y equals 11. This must equal 8. 3 plus 8 equals 11. So y must equal 2. Because 4 times 2 is 8, plus 3 is 11. And these are the two solutions to this pair of simultaneous equations. So to summarise, look at the y part in each equation and think, what can I do to the equations to make the numerical part of the y's equal each other? And then, if they've got the same sign, we subtract. If they've got different signs, we add. The y's therefore cancel, so we find x, and having got x, we can then find y by putting x into one of the equations to find what y must equal. The final two examples are classed as more advanced, and it actually goes under the name of substitution. Now this is the main equation here. It's got x and y's in. However, I know from the first equation y equals 2x plus 1. So I can replace the y in the second equation by 2x plus 1. So x plus 2 lots of y must equal 17. I then expand the bracket, simplify, subtract 2 from both sides, therefore x must equal 3. And then for the easy part, if x equals 3, y must equal 2 lots of 3 plus 1, which equals 7. And these are the solutions to this pair of simultaneous equations. The final example is similar. We have a main equation and a y equals equation. So we go to the main equation and we replace the y by whatever we're told it equals. We're told y equals x plus 1, so that y is replaced by x plus 1. So x squared plus 3 times y equals 1. I expand the equation, and then because it's quadratic, I want to make the equation equal to 0. So I subtract 1 from both sides. This equation factorizes. Because 1 times 2 is 2, and 1 plus 2 is 3. Therefore, the solutions must be x equals minus 1 and x equals minus 2. Because if you factorised, the solutions are the numbers in the bracket with the sign change, because minus 1 plus 1 equals 0 and minus 2 plus 2 equals 0. And then to finish off, y equals x plus 1. So when x is minus 1, y equals minus 1 plus 1, which equals 0. Or, if x equals minus 2, y equals minus 2 plus 1, which equals minus 1. And these are the two pairs of solutions to this pair of simultaneous equations. This video looks at how we can solve where a reciprocal graph intersects a quadratic graph using simultaneous equations. Now, where these two graphs intersect, the y-coordinates must be equal. So therefore, at the point of intersection, we can say that 1 over x minus 3 must equal x squared minus 4x plus 1. So the two equations must be equal to each other. So therefore, I need to solve where these two equations are equal, i.e. solve this equation. So if I put brackets around the bottom and the top, like so, and then times up by x minus 3, I get 1 is equal to x minus 3 bracket x squared minus 4x plus 1. So if I now expand this right hand side, I get 1 is equal to, so I times by x through and then times by minus 3, x cubed minus 4x squared plus x, and I times by x, take away 3x squared plus 12x minus 3, and I times by minus 3. If I then simplify, 1 equals x cubed minus 7x squared plus 13x minus 3, then set equal to 0, 0 equals x cubed minus 7x squared plus 13x minus 4. So that is the equation which I need to somehow solve. Now let us suppose that we were told that one of the solutions is that x is equal to plus 4. That is a root of this equation. And we want to find the other two solutions if they exist. Now if we know that x equals 4 is a root, then therefore we know that x minus 4 is a factor. So to find the other factors and hence the roots, I divide this expression by x minus 4. So I want to work out what x cubed minus 7x squared plus 13x minus 4 divided by my factor is. Now for this I use a grid method. So I put my factor of x and minus 4 down the left hand side, and then work through as follows. Okay, I want an x cubed. So therefore x times what is x cubed? Well, x times x squared. And minus 4 times x squared is minus 4x squared. But I want a minus 7x squared, so I need another minus 3x squared up there. These two terms combine to give minus 7x squared. I've already got an x, so I need a minus 3x. Now minus 3x times minus 4 is plus 12x. I need a 13x. I need one more x. And x times what is x? Well, x times 1. And to check this, 1 times minus 4 is indeed minus 4 as required. So therefore, if I divide through by x minus 4, I'm left with the top line, which is x squared minus 3x plus 1. So therefore, this whole thing here factorises to x minus 4 bracket x squared minus 3x plus 1. That's my known factor, which gives my known root. To find the other two solutions, I must somehow try and solve x cubed minus 3x plus 1 equals 0. And to do that, I would probably use the quadratic equation. So x is equal to minus b, which becomes plus 3, plus or minus the square root of b squared, which is 9, minus 4 times a times c, which is 4, all over 2 times a. So x equals 3, plus or minus the root of 5, all over 2. So I've got one given solution to help us solve the equation, followed by the other two roots down here. In this question, we're asked to solve two simultaneous equations. Now, in my view, the best method is to times both equations by a different number to get the same number of y's. So we have the same y coefficient. Now 2 and 5 both go into 10. So if I times the first equation by 5, it becomes 15x plus 10y equals 20. And if I multiply the second equation by 2 instead, I get 8x plus 10y equals 34. If I now subtract the second equation from the first equation, the y's cancel out. 15x take 8x is 7x. The y's cancel, and 20 take 34 is minus 14. So 7x is minus 14. X is therefore minus 14 divided by 7, which is minus 2. So I found that x is minus 2. And to find y, I sub this value into any of the equations we have. I will pick the first one. So 3 times x plus 2 times y equals 4. So 3 times minus 2 is minus 6, plus 2y equals 4. If I add the 6 to the other side, I get 2y equals 10. If I then divide by 2, y equals 5. So the solutions are x equals minus 2 and y equals 5. And they are the solutions to the simultaneous equations. In this video we solve a pair of simultaneous equations. Now the way to solve this is to times both equations by a different number to make the y's have the same coefficient. Now 2 and 3 go into 6. So if I times the first one by 3, I get 15x plus 6y equals 33. If I times the second one by 2, I get 8x minus 6y equals 36. Now, if I then add together the two equations, the 6y and the minus 6y will cancel out. So 15 plus 8 is 23x. They cancel out. 33 plus 36 is 69. So 23x equals 69. This says that x must equal 69 divided by 23, which equals 3. So I found x, but I must also find y. I therefore sub in x equals 3 into any of the equations. I'll pick the first one. So 5 times x, which is 3, plus 2y equals 11. That tells me that 15 plus 2y equals 11. If I take 15 from both sides, 2y equals minus 4. So y equals minus 4 divided by 2, which is minus 2. So my solution is x equals 3 and y equals minus 2. This video looks at two examples of quadratic simultaneous equations, and it shows how you can find values of x and y algebraically which satisfies both equations. So in example 1 we are given two equations, and the question is, where are these two equations equal to each other? In other words, where are the y's equal? But if the y's are equal, then therefore these two expressions here must also be equal. So the question is asking, where does x squared plus 7x minus 2 equal 2x minus 8? Now to solve this sort of equation, you need to get all your terms to one side and have equal to 0. Now the x squared term's on the left, so I want to get rid of the 2x by taking away 2x. And I want to get rid of the minus 8 by adding 8. But what I do to the right hand side, I must do to the left hand side. So if I take away 2x, I get a 5x, and if I add an 8, this becomes plus 6, and the right hand side is left as equaling 0. So this becomes quite a simple equation to solve, because it factorises. 2 times 3 is 6, and 2 plus 3 is 5. So we're left with x plus 2 and x plus 3 equals 0. So these two things times to make 0. So either x is equal to minus 2, because minus 2 plus 2 is 0, or x must equal minus 3, because minus 3 plus 3 is 0. Now we're almost finished, but there's a y value as well, and we know y equals 2x minus 8. So if x is minus 2, y must equal 2 lots of minus 2 minus 8. Well, 2 times minus 2 is minus 4. Take 8 minus 12. Or y is 2 times minus 3 minus 8, which is minus 6 take 8, which is minus 14. And there are answers. Actually, two sets of coordinates. The first coordinate is minus 2 minus 12. The other coordinate is minus 3 minus 14. So these values are the solutions to these two equations, and it's where the actual curves and lines intersect. Now in the second example, it's similar, but whereas these were both y equals, this one's y equals, but this one here is not. However, there's a little trick we do. Now this y here, where they intersect, where they're the same, must equal this y here. So, if we look at the first equation, we have an x squared plus a y squared. But we know that y equals x plus 4. So I can replace this y by an x plus 4. So we get an x plus 4, where the y was, but it's squared. And this must equal 8. We now expand this. Now don't forget that x plus 4 all squared means x plus 4 bracket x plus 4, and that equals 8. Now to expand this, you use your normal expansion of brackets. It gives us an x squared, 4x and 4x is 8x, and 4 times 4 is 16. We have an equals 8, and we have an x squared. We then simplify. X squared plus x squared is 2x squared, plus an 8x, plus a 16 equals 8. We now want it to equal 0, so we must take away 8. So that will cancel off. However, if we take away 8 there, we must do so there as well. So we get 2x squared plus 8x plus 8 equals 0. The next trick is to look for a common factor. I can divide by 2. So I'm left with x squared plus 4x plus 4 equals 0. This now factorises. 2 times 2 is 4, 2 plus 2 is 4. So we get x plus 2 equals 0. And so the solution, and the one solution, is x must equal minus 2. Because minus 2 plus 2 is 0, and the same in that bracket there. Almost done. Y is equal to x plus 4, which is minus 2 plus 4, which equals 2. And the coordinate we're left with is minus 2, 2. Now there's one bit of language which you'll meet certainly in AS maths if you choose to do so, which is when there's only one solution, it's called a tangent. In this question we're asked to solve two simultaneous equations, both of the form y equals. Now the method here is to substitute, because I know that y equals x plus 4. So this y here can be replaced by x plus 4. So I get x plus 4 equals 2x squared plus 3x minus 1. Now to solve this equation I need 0 equals. So if I take away x and take away 4, I get 0 equals 2x squared. I've taken away x, so I get a 2x. And I've taken away 4, so I get a minus 5. So I need to now try and solve this equation. Now to solve this, I can use the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a, where a in this case is 2, b is also 2, and c is minus 5. So I put these values into the formula. So x will equal minus b, well b is 2, so minus 2, plus or minus the square root of b squared is 4, minus 4 times a times c, which is minus 5, all over 2 times a, which is 4. Right then, I'll now work out the square root part. Now we're taking away 4 times 2 times minus 5. 4 times 2 is 8, times 5 is 40. There are 2 minus signs there, so it's 4 plus 40, which is 44, all over 4. So I can now work out two values for x using my calculator. So, fraction button, minus 2, I'll do the plus 1 first, plus root of 44, and then divide by 4. So minus 2 plus root 44 over 4 gives me the answer of 1.16 to 2 dp, or I can change it to a minus root 44, and I get the answer of minus 2.16 to 2 dp. And then to find y, I will then just add 4 to these values. So 1.16 plus 4 is 5.16, or minus 2.16 plus 4 gives me the answer of 1.84. Again, to 2 dp. So I have found two pairs of answers for x and y, both to 2 dp. This video looks at how we can use matrices to solve a pair of simultaneous equations. Now we can write this in the form 5 minus 2, 3, 7. So they're the coefficients. X, y is equal to 4, 1. So these two statements, or pairs of equations, are equivalent to each other. Now, if we then let M equal this matrix here, then to solve this pair of simultaneous equations, we find the inverse. So, we swap the 7 and 5, we change the signs, and we do 1 over a times b minus b times c. So this becomes 1 over 41, 7, 2, minus 3, 5. So we found M inverse. Then to find x and y, we times both sides of the equation by the inverse. Because if we times by M inverse and M inverse, then this matrix here will cancel out. So we're left with x, y is equal to the inverse times by 4, 1. So again, I've times both sides by M inverse, therefore that will cancel out to leave just the x and y. We then work out what this becomes. So I leave the factor of 1 over 41, then 7 times 4 is 28, plus 2 is 30, minus 3 times 4 is minus 12, plus 5 is minus 7. So therefore we get 30 over 41, and minus 7 over 41. So x equals 30 over 41 and y equals minus 7 over 41.